Hi, everybody. Thanks for having me here in Cloud Village. And let's begin. So, about me, well, everybody, my name is Felipe Espósito, and I'm also known as Pr0teus. I'm a security researcher from TNT Security. It's a startup focused on cloud security. That is my handle in Twitter and my email address described below. And I'm from the beautiful and dangerous city of the Rio de Janeiro, Brazil. So, my motivation for this talk. Every other day we have some data leak, mostly because of some S3 buckets were misconfigured or anything related like that. But there's nothing wrong with S3 buckets getting that much of attention. They are probably the most prevalent and easy to find misconfigured AWS resource on the internet, and it stores a lot of data. So yeah, and gray hat warfare is my weakness. There are at least 394,000 public S3 buckets holding more than 6 billion of documents. And that's a huge amount of documents, right? Yeah. But AWS has other services too. And some of those services can also be misconfigured and exposed to the internet as well. And today we are going to talk about 6 of them. But first, in 2020, Scott Piper published a list of AWS exposable resources on GitHub. And this list has 20 or more exposable resources, and that can be exposed to the public or to another AWS account. The list is on GitHub. It's pretty easy to find. It's pretty easy to anyone to understand which AWS API you have to reach to or request to expose that resource. And based on that list, we choose some services to understand a little bit better, try to hunt them a little bit better about that service and try to hunt them on the internet. So another pretty interesting project was Endgame from Keenan McQuaid. He released a new tool early in this year that was capable of backdooring AWS resources by making it public or exposed for another AWS account or an attacker account. And this kind of tools, it's helpful to show us the impact of a backdoored AWS resource that you can have on different environments, and helps blue teams to create detections for that. So cheers for McQuaid for doing that for us. And in 2019, Ben Maurice did a great job by analyzing exposed EBS volumes. EBS volumes are like hard drivers when you attach to a EC2 instance, and you store things there, right? And for those EBS volumes, they can be shared with another AWS accounts or make it public on the AWS. So he did a great job by analyzing those public EBSs. He was able to review some security, source codes, and PII stuff. But in order to find those EBS, he just had to carry the AWS API to get a list of those resources. So it's what kind of easy to find those resources. So he did a great job. He did a great talk. He had some challenge to solve, and he did it pretty well. So congrats for him. But all those exposed resources and data, they came from somewhere. I'd like to say sorry first, because as some gymnastics at the Olympics have some obligatory movements, we do have an obligatory slide to cover before diving to AWS Managed Resources. And that is the shared responsibility model. Yeah, unfortunately. Okay, so the shared responsibility model dictates that AWS is responsible for patching, updating, and maintaining the managed and resources. And the customer is responsible for configuring the resource policy, security groups, and for security their data. So all those data that I found in this research was only possible because customers failed in protecting their own stuff. And just some stats. So pretty quickly, I was able to find at least 20 public read SQS queues, 19 public write SQS. I also able to reach more than 690,000 cloud search documents, more than at least 30 undisclosed active MEQ, and more than 5 terabytes of exposed data on Elasticsearch itself. And just a little bit quick disclaimer, and it's important to note that I didn't X any of those data. I just counted the data that was possible to count without touching it. So I don't want to go to jail, and that's it. So for the data sources, which data sources I choose to try to find to hunting for AWS services? Well, I choose 2 data sources for passive DNS, RiskIQ, the community one, and SecurityTrails. SecurityTrails is $50, it's not that expensive. So yeah, it's a good source. I have some other OSINT techniques like Wayback Machine, subdomain enumeration, and code repository. So for a code repository, one thing that I did, and it was pretty interesting, is to get the SHH Git project. It's a project that it's on GitHub, and their objective is to, it keeps carrying the GitHub API for trying to find some secrets, credentials, passwords that were leaked when a developer commit the code to the GitHub. So I just modified to find AWS endpoint services. Also, I had the idea to use the Google Cloud BigQuery to search for AWS resources in a public data source. So GCP has a public data source from GitHub, and it backs to 2019 and have more than 2 terabytes of data. So it seems to work to checking out. Right. And finally, I wrote some Python scripts to carry the GitHub Search API endpoint. And the problem is that the API endpoint is only comes back with the first 1,000 results. So I had to play a little bit around to implement some tweaks and dorks to get enough relevant data. But the good side, the advantage of carrying the GitHub is that some resources can be protected by username and password. And sometimes developers make the mistake of committing them with the codes they are writing. So it's worth looking into. Sorry. And for subdomain enumerations, I read a really good blog post from Ricardo Iramar. He wrote an article doing a comparison of 9 subdomain enumeration tools. And based on those findings, I picked the following for this research. I choose to use FindDomain and MS. MS from WASP, it's capable of getting information from several sources like Wayback Machine, DNS dumpsters, and Rapid DNS, for instance. So we also try to use Shodan Censys for a few specific cases. We show the results on slides to come, but no, that was not that successfully. And by discarding the data sources, I try to use certstring to try to identify some unique URLs. But as we are going to see that AWS is using wildcard certificates for most of the services, which makes certstring of no use in identifying individual host names. But as we are going to perceive during the talk, that most of AWS resources has a random component in the DNS, and that must prevent from brute forcing. But the certstring, we can see the handle part on certificates. So we only need to find the name provided information when you create that resource. But that would be like a brute force and a shot in the dark. And brute forcing wasn't in scope for this research. And I didn't try that. I didn't went for that way. Right. So I do have some metrics here. I call it valid DNS. when the host name I got a first name and it resolves for IP address, that means that resource on AWS is still active. And I call it public IP when that IP resolved from the previously URL are not in the RFC 1918 on the private ranges. So yeah, I choose these two metrics to decide which data source would be a good one. So the first managed services that I explored was DocumentDB. And I know that we can't directly access DocumentDB from the internet because it's always deployed in a VPC. And that means that we need at least an EC2 instance inside of that VPC to connect it first and make a tunnel through it to connect to the DocumentDB database. But I was able to find some instances on the Censys that have a HTTP proxy tunneling the DocumentDB to the internet. Well, people get creative ways to expose their data, right? Yeah, and from DocumentDB and those data sources, for example, what I call historical GitHub, it's the GitHub from the Big Carry search, and then I got 7 unique results. GitHub search by carrying the API, I got 117. Security Trails came back with 33 results, and PaySafeTotal with just 1 from RiskIQ. But the true results are that only 37% of the domains that I found was valid. So 62% of that was old enough, or this was not valid at all. And the most percentage of valid DNS came from Security Trails, followed by GitHub Carry. So PaySafeTotal is just a little bit. Another service that I tried to explore was the Amazon MEQ. And when you create an Amazon MEQ, by default, you have two kinds of MEQs to choose, two kinds of queues to choose. You can choose between RabbitMQ and ActiveMQ. When you create an ActiveMQ, by default, it's created inside a VPC, and it has a security group to protect it. So it's not directly exposed to the internet. Unless the administrator changed the security group to allow 000 inbound. But when you create a RabbitMQ, on the other hand, it's all exposed directly to the internet. So it's only protected by login and password that you create when you create the RabbitMQ, right? So I was able to find more than 4,000 RabbitMQs in Shodan, and that's pretty straightforward. And for the rest, I was able to find around 1,500 on MS Find Domain, 2 on historical GitHub, 5 on GitHub Search, and 145 on Security Trails, and none on PaySafeTotal. But, well, this is the print screen from Shodan. So just, we have 116,600 only for US East 1. And it's pretty straightforward, just click it on. If you know the username and the password, you can just log in and see the queue, right? But what about unique URLs? We found around 200, 300 around something unique URLs, but the most valid unique URLs came from MS and Find Domain. If we check 2 slides before, MS and Find Domain has 563 unique URLs, and Security Trails has 145. But when you check for valid URLs, Security Trails is almost close to MS and Find Domain. So, yeah, and you remember that when I said ActiveMQ that you have to change the security group to allow 000 inbounds? Yeah, we found at least 30 cases where the admins did just that. So I was able to access the console of the ActiveMQ by just doing HTTP GET on the URL and the port to H162. Yeah, well, another managed service that I tried to explore was Amazon Cloud Search. And Amazon implements an elastic load balance in front of the cloud search. So, and one interesting thing to note that the cloud search, you have to choose a name, then comes the random string, the region, cloud search in Amazon AWS on the URL. So looking for that in Shodan, I could reach at least 38,000 cloud search servers on the internet. But in Shodan, you only have the IP address. So as Amazon implements elastic load balance in front of it, without knowing the DNS, we are not able to get the correctly virtual host, which leads us to only amass, GitHub, and passive DNS as data sources. And for those data sources, I tried to check if DNS was valid and try to do an unauthenticated research for letters E or A. Because I choose those letters because they're really common in almost all languages. And if the resource policy of the cloud search was set to star, I would be able to carry those letters, right? So yeah, just checking by valid DNS, I found that Pr0teus was the most prevalent with more than 30, a mass find domain around 10, and passive DNS with only 2 valid DNS. But on those 42 valid DNS that I found, I was able to reach at least 609,000 documents. So it's a huge amount of data, right? Well, and another service that I tried to explore was Amazon SQS. And Amazon SQS are exposed by URL. So it's kind of tricky because if you have an URL, all the SQS region.amazonaws.com are valid. They resolve for IP address, but the queue might exist here or not. So that completely makes passive URL subdomain enumeration technique is completely ineffective. So we only had historical GitHub and GitHub search to try to hunting for Amazon SQS. And by doing this research, I just found that more than 450 URLs from GitHub historical was not public, so I couldn't read or write. But I found that at least 20 was public readable, and at least 19 of that SQS was readable and writable. The interesting part of the public readable is that you can intercept the messages from their pipeline and perhaps get some important piece of information. And for those who are publicly writable, it can lead for more serious vulnerabilities like SSRF or any remote code execution by just depending which part of the code will consume the messages from the queue. For instance, if we have a Lambda with some kind of vulnerability and we will be able to write anything that we want unexpected to that Lambda might exploitable. And the other services that I tried to reach was Amazon RedShift. And Amazon RedShift, it's like a PostgreSQL database, like a cluster of data warehouse. And also Amazon exposed RedShift through DNS entries. So every time Amazon exposes something as DNS entries, it's like 1-to-1 for DNS and IP address. When it's by elastic load balance, you might have 2 IP address or more for that entry. So it's kind of easiest to find Amazon RedShift. So to publicly expose a RedShift database to the internet, you must, 1, create an elastic IP address, and then configuring the RedShift to use the elastic IP address to use that elastic IP address you created before. And then you have to change the security group to allow 0000 inbound. For RedShift, Amazon Find Domain was able to find only 42 results. Historical GitHub only 7, GitHub search around 192, and Pr0teus 226. Passive total only 2. But checking by if they are valid or not on the unique DNS, most of the part of security trails were valid. That is an IP address that resolved to that DNS. And for GitHub Carry, it's less than a MS5 domain. So a MS5 domain was able to find that 19% of valid DNS by source instead of GitHub Carry, right? And one interesting thing to note is that interesting thing to note is that I couldn't find any Amazon RedShift public exposed to the internet. So can I hear an hallelujah? Yep, it's at least one good thing. So, and the last service that I tried to find and trying to explore was AWS Managed Elasticsearch. And when you create an Elasticsearch, you have to choose if you want to create it public or inside a VPC. When you create it inside a VPC, you get the following host name. You get the VPC dash name dash random string dot region dot as dot amazon.com. And when you create a public one, which means that they're reachable from the internet, you have the host name like search slash name random region yes amazon.ws.com. And Elasticsearch is also exposed through Elastic Load Balancer. So we needed to know the name, the exact name from the host to get the exactly the host. And for Elasticsearch, you can also choose the type of authentication. So you can choose between Cognito, Basic Auth from HTTP, AIM, none, and a little more Open Distro has another configuration that's a bit more specific. Well, but looking for our public Elasticsearchers, Scott Piper published on a Forward CloudSec Slack group that he was able to find at 1 year ago 387 public AWS managed Elasticsearches, and the last time he reported in February, he were able to find 359. He advised to AWS to close those publicly reachable AWS managed services, and I tried to reproduce his search, and I'm only able to find 5. So yeah, AWS made a really good job closing those publicly managed Elasticsearches. But what I believe what they did was to put a load balance in front of them, so we couldn't be able to reach them directly by IP address. Well, some stats for managed Elasticsearch. By looking for valid DNS per source, Security Trails was able to find more than 1,000 valid DNS, followed by passive total, MS, domain, GitHub Carry. GitHub historical was way down. But the percentage of valid DNS that I found was only 41%. So 41% of all the hosts that I found was valid. Right. Well, and those who are valid, and I try to get some information, I was able to determine that more than 800 was the IAM authentication type. A little bit more than 100 was open to the internet, and a little bit less than 100 has basic authentication. And for those which were open, I counted 11,000 number of indexes and at least 5.1 terabytes of data that was exposable to the internet as well. And when we try to understand which data sources are public by source, we found that Security Trails has 58% of the publicly open Elasticsearch managers. But when we try to compare that with the amount of data that was exposable, MS with fine domain has more than 40% of that. So if you're trying to look for exposed data, Amazify domains a little bit more better than security trails in that case. So, yeah. So some closing thoughts. Well, take the shared responsibility model seriously, and please do it well. Make sure you're not exposing any of your data. Find EAM resource policies that allow principal, star, or equivalent. And for this, you can use some security tools to automatically detect and mitigate those kind of misconfigurations. For instance, CSPM, Security Hub, or AWS config rules. And due to the dynamic nature of the clouds, historical GitHub make data was obsolete. So as the data stops in 2019, most of the services who were created and destroyed by then were not on validity anymore. So we spent around $250 in big carry searches for almost no valid hits. So yeah, sorry, boss. Well, and passive DNS has partial visibility of the cloud infrastructure, but is still a good source for hunting for AWS managed resources. So yeah, that's all that I have for today, guys. Do I have time for questions?